As discussed, we will start the concept of functions. This is a new concept of C, again a new concept that we will learn in C. What is functions? What are functions? See, for that what I will firstly do is, I will take over an old program and try to write it. What is the program that we will write? Again, sum of a series. You remember we calculated the sum of so many series. We will write the program for calculating the sum of a series. So, sum of a series means, say the series can be like this. I want to calculate 1 factorial divided by 2 square root, that is square root of 2, I think you understand. 1 factorial divided by square root of 2 plus 2 factorial divided by square root of 3 plus 3 factorial divided by square root of 4 3 factorial divided by square root of 4. In this way, if I continue, I may continue up to the nth term. So, the nth term means, if first term is 1 factorial divided by 2 square root, second term is 2 factorial divided by 3 square root, the nth term will definitely be n factorial divided by square root of n plus 1. Please understand this. It will be n factorial divided by square root of n plus 1. Isn't it so? So, this means the sum will be this one. So, how to calculate the sum of such an expression where n will be entered by the user? Very simple. So, the program I will try to write with whatever skills we have or learned till now, whatever the features of C we have learned till now. For that, I will firstly ask for the user for entering the value of n. So, printf enter n should be the first thing I tell the user. I must scan it from the user, scanf %d ampersand n. So, this n is now in my hand. Now, definitely a for loop should be there, which should start from I equal to 1 and continue up to I less than equal to n I plus plus, so that for each term I can calculate. Now, you can understand that for this what I need to do firstly is calculating the factorial. So, see, if I have got the factorial of I minus 1 in my hand already in a variable called fact, then I can easily write fact into is equal to I. Cannot I write that? Fact into is equal to I means I am multiplying I with previous factorial. I assume that the previous factorial is factorial of I minus 1 is already there in fact. I just multiply I with it to get the factorial. Say 2 factorial is already there in fact. So, if I multiply 3 with it, I get 3 into 2 factorial, which is 3 factorial. So, if I multiply 4 with 3 factorial, I get 4 factorial. If I multiply 5 with 4 factorial, I get 5 factorial. So, I am assuming that the fact of I minus 1 is already there in fact variable. I just multiply I with it. And how do I assume that? I can assume by writing, initializing fact equal to 1. If I have got fact equal to 1, then firstly 1 into 1, factorial of 1 is 1. So, 1 into 1, 1 will get into fact. So, fact is now containing 1 factorial. Next time when I come to the loop, I is 2. So, if 2 is multiplied with this 1 factorial, I get 2 factorial. So, fact contains 2 factorial now. Next time when I come back, I is 3. So, this time 3 will be multiplied with 2 factorial. So, definitely I will get 3 factorial. So, fact contains 3 factorial now. Next time when I come back, I will be 4, but fact contains 3 factorial. So, 4 multiplied with 3 factorial, fact becomes 4 factorial, and so on. So, fact will contain, so easily I can make fact contain the factorial of I. But I need the square root of I plus 1 also. So, for that square root of I plus 1 can be any floating point number. So, if you remember, I will start with a floating point number j equal to 1.00. Because the lowest thing that is possible is square root of 2. Square root of 2 I can start from checking by 1.00. 1.00 assuming as the lowest square root that can be possible ever. Because 1 square root is 1, but I will start from 2 square root, finding 2 square root. So I can safely start from 1.00 trial, I can start. I don't know how long to continue, but one thing I know that I will have to check for every number starting from 1.00 and continuing like 1.10, 1.20, 1.01, 1.02, 1.03, 1.04 and so on. I will check each and every fraction whether it's a factorial. 1.01, 1.02, 1.03, 1.04 and so on. I will keep on checking for every number whether it's a factorial or whether it's a factorial of I or not, it's a square root of I or not. So how do I know whether it's a square root of I? If this j into j becomes equal to your n, you know you have got the factorial. See, I have started from 1.00, I am checking whether 1.00 into 1.00 is n. Then I am checking 1.01 into 1.01 is n. Then 1.02 into 1.02 is n. But the problem is this n may not exactly match. It may just be below n or just be greater than n. So what I do is I check for greater than equal to n. That is whether j into j just exceeds that n, not n over here. What do I need to check? I plus 1, because when I am starting with I, then I need to do 2 square root. When I is 2, I need to do 2 factorial by 3 square root. When I is 3, I need to do 3 factorial by 4 square root. So I need to do the square root of I plus 1. So I am checking whether the j into j that I am trying has just exceeded I plus 1 or not. Whether it has just exceeded your I plus 1 or not, j into j. If so, if j into j has just exceeded I plus 1, I can say that I have got the exact square root. That means I can break out. It will just exceed. I have got the square root. I have just got the number which is just greater than the square root. So I have got more or less the exact number. So I break out. So I know when I break out, j contains the square root. But I is a floating point number. So just to be on the safe side, though you can compare like this, but just to be on the safe side, it is better to convert it to float. And because you are doing j into j, you can also give a bracket over here. All these are just not money. It's not a necessity that you must give, but you can give. So j into j greater than equal to float of I plus 1. I am comparing, this is j is float, but I am comparing with I plus 1 which is int. So I am checking this. If j into j greater than equal to float of I plus 1. Then I break. When I break out, I know one thing for sure, that j contains my factorial, this square root, and fact contains my factorial. So can I write the sum plus equal to, what I need to add with sum is fact divided by j. Sum is fact divided by j. Now j is float, no doubt, because you will define j as float definitely. You are using j as float, okay? And you are not putting any end condition over here because you will break out normally. So anyway, j is float. Fact is an integer. Sum has to be float because these are all floating point numbers. So you can change fact to float if necessary, but again then this is not absolutely necessary, because j is float, sum is float, int by float will automatically become float. But still, just for your safety, you can change it to float, typecast it to float, and then divide by j. In that case, this becomes, numerator becomes float, denominator becomes float, and definitely the result you are also holding in float. Sum has to be float. So in this way you have got the sum. What you can do over here, you can simply write sum of the expression is this, printf, the sum of the expression is %f, you can write, and this %f has to be replaced by what? Has to be replaced by sum variable. This sum is your floating point, is a floating point number, replaced by the sum variable. Definitely end with a get ch, and this is your program. You need to only declare. What are the variables you need to declare? You have used an integer n, you have used an integer I, you have used an integer fact. These things are integers that you have used. You have used the floating point number j, you have used the floating point number sum. Anything else that you used? I don't think so. So this much is your program. You can run the program and check. Definitely it will run properly. Let me comment this out and run this program. Enter n, so say n is 5, you enter. This is the sum of the expression. You can check it out. You can just do a small calculation and check it out. Enter n 5 means I am calculating 1 factorial by 2 square root plus 2 factorial by 3 square root plus 3 factorial by 4 square root plus 4 factorial by 5 square root and plus 5 factorial by 6 square root. So this is 64.53. If you enter n as 4, this is something, when you write enter n, put a colon and a gap so that it looks nice. Now let me run it with 4. It will be a smaller number, 4. It is 15.55. With 3 it will be an even smaller number, 4.38. With 2, 1.85. We can do easy calculation. 1 factorial is 1 divided by square root of 2, 1 divided by 1.41 plus 2 factorial is 2 divided by square root of 3 is 1.72. So 1 by 1.41 plus 2 by 1.73 is 1.85. We can do an easy calculation and check out. So this program runs fine. But now what this has got to do with function? It says that this program could have been so easy for us to write, easy for a programmer to write. Function only helps a programmer to make his programs easy to write. You could have made this program so easy to write using the concept of function. How? What you can do is, suppose if you could have written the program as simple as like this, I will get rid of all these integers, floats that I declared. I go back to the point, exact point where from I started the program. So this can stay, because ultimately I will have to print the sum. So this can stay. But all these things, all these declarations I just remove at the beginning. I will declare latter. Now this for also I am removing for the time being. I will write latter. What I am trying to say is, how can I make this program so easy? I know I can write it like this. If suppose I could have written factorial of I, if I could have written something like this, if C could have allowed us to write something like this, factorial of I, then I know for I equal to 1, factorial of 1 will be calculated. If I is 2, factorial of 2 will be calculated. If I could have written like this, if I could have written factorial of I and could have got the answer, could have got an answer back, say an answer called x. If I write something like this and it would have worked, please understand my point, what I am trying to say. Factorial of I just write fact I, and if I expect that x equal to fact I will give me the factorial of I in x. Similarly, if I could have written something like this, y equal to square root of I plus 1, or maybe square root of j, in this case I plus 1, but normally say square root of j, and got an answer, the square root of j within y, my job could have been so easy. In the for loop, I could have written x equal to fact I, y equal to square root of I plus 1, and then divided x by y and got the answer. Please understand what I mean to say. What I mean to say is something like this. Say if I could have written like this, for I equal to 1, I need to go up to n, I less than equal to n, I plus plus. If I go up like this, and then I can write a statement like this, say for example, as I was telling you, x equal to factorial of I, and expect that the i's factorial will be there in x. And then if I could have written y is equal to square root of I plus 1, and then expect that y will contain the square root. My life could have been so easy. What would have happened? I would have entered initially with 1. Fact of 1, I expect x to be fact of 1. Square root of 2, I expect y to be square root of 2. So 1 factorial divided by 2 square root could have been done so easily by x by y. Next time I would have entered with I equal to 2. Then again x equal to fact of 2 could have been done so easily. And square root of 3 could have been done so easily if I could have written like this. And then again x by y would have given me that term. So what I meant to say over here, I could have written sum plus is equal to x by y. I could have written sum plus equal to x by y and expect that ultimately the sum will contain the sum of the expression, and then I could have printed it. I think you understand what I meant to say. But my question is this possible? Can I write something like this? Answer is yes, by using the concept of functions. What you do is, you write this function yourself. That is, this main is there. This main is working. Main itself is a function. Have a look at it. Main itself is a function. Out of main, you write a new function called fact. Actually, when you are saying fact I, you are as if calling this function which will do its job and return the factorial. Do you get my point? When I am saying fact I, it means basically I am calling a function called fact. To that fact function, I am passing this I, passing on this I, whose factorial I want. Fact receives that I, whichever factorial I want, and returns the factorial value which is now received in x. I think you understand. So in fact, what I can do is, fact I can receive this int, say n, whose factorial I want to do. See, I define fact, and definition of fact will go like this: int fact, int n. It will mean that factorial is a function which will receive any value within a variable called n and will return an integer. That is, it will receive the n, whichever factorial needs to be calculated, and the factorial of n will be calculated within this function, and that factorial is an integer which will be returned to the point from where it was called. So say fact I calls this factorial function, passes this I, means the value of I. If I is say 4 at any point of time, then this 4 is passed from I. This 4 is passed from I. And this n receives this 4 and calculates the factorial. That is, n will receive 4 and calculate the factorial of n means calculate the factorial of 4. Next time your I will become 5. So when this I becomes 5, fact I will again call the fact function and pass this I. Where will this I be received? This I will be received in the variable called n, that is 5 will be received in n. So fact will calculate the factorial of 5 and will return that factorial of 5, which is definitely an integer. And where will you receive that? When you return, where do you receive? You receive with it over here, which you are then assigning to x. You are receiving over here, which you are then assigning to x. I think you understand this. This I will then become say 6. So when you are calling this fact I, you are passing this 6. Where do you receive it? You receive it in int n. N becomes 6. Factorial is calculated and then it returns an integer, that is the factorial of 6 is returned. Where do you receive it? You receive it from at the point where you called it, and this is then assigned to x. So this is actually calculating the factorial. Please understand how this fact has been defined. Int fact, int n. Fact is a function which will receive an integer, calculate the factorial and will return that. I think you understand. So over here, what will I do? I will calculate the factorial. Over here, I can take another variable I, doesn't matter. This I has got no relation with this I, because this I is there within main, this I is there within fact. This environment of fact is different from the environment of main, which means the variables declared within main like n, like I, has got no relation with the variables declared within fact. They do not actually disturb one another. This n is local to fact. This I is local to fact. This I is local to main. This n is local to main. They have got no relation. Only relation is value of I has been passed to factorial, fact function, which has received it in n. From then onwards, there is no relation between the I of main and the n of fact, or the I of main and the I of fact, or the n of main and the n of fact. No relation with one another. Only relation that is there is value of I has been passed to the fact function, who has received this value of I in the int n. Do you understand this? So this now can use its local variable I, which has got no relation with the I of main. It can work independently. Now it can say for I equal to 1, the factorial being calculated, I less than equal to n, I plus plus, you calculate the fact like fact, you cannot use fact because fact is the name of the function. This function knows fact is the name of the function. It's better not to declare any variable called fact, or you cannot declare a variable called fact. Let us have a variable called product. It's all the same. Product into is equal to I. How long? So this product will contain the factorial of n at the end. Please see, I starts from 1 up to less than equal to n. For every I is multiplied with product. If product is initialized to 1, then it starts from 1. 1 will get multiplied, then I becomes 2, 2 will get multiplied, then I becomes 3 over here, 3 gets multiplied, then I becomes 4 over here, 4 gets multiplied. So 1 into 2 into 3 into 4, everything getting multiplied up to n. So definitely product at the end will contain the factorial of n. So over here, you know, when you come out, your product variable contains the factorial. In fact, that is the thing you want to return. So what do you write? Return product. If you write return product, then what is happening is this product, which is the factorial, is returned. This you are talking about. Here you declared int. It means that this int is actually this product you are returning. You notice one thing, you cannot return two things, because over here you can only write int or float. You cannot write two int, comma int, you cannot write like that. That means you can return only one variable. So product is being returned. So product is being returned means this product is returned where? From the point where it was called. See, during calling, you don't need to write int fact, int I, something like that, because you are passing the value. And you are passing the value to the fact function. Here you are defining that the fact function is like this. It receives it in an int n. You are declaring the int n over here. In int n, you are receiving that value I, and that you will return an integer, which you are doing over here. So you understand this? So what will happen as a result? This fact I will call the fact. See, while writing, if you have such a fact function ready in your hand, then you don't need to think of anything else while writing the main code. Writing the main code becomes so easy. You are actually dividing your program into parts. You know, for writing such a program, factorial needs to be computed. So you compute the factorial separately. Any n, its factorial is computed like this. Similarly, you will calculate the square root separately, And while writing them in, you are just using the factorial function and the square root function. So the square root function will pass on the value of I plus 1 to the main function where I will receive it. So what will square root return? Square root will return a float. It will calculate the square root of I plus 1 means the square root of I plus 1 can be any float number. So it will return float. So it will look like float followed by square root. Where do you receive it? Again you can receive it in int n. Doesn't matter, you can say, see, I have used n over here. This n and this n has got no relation. The environment of main is different from the environment of fact, which is different from the environment of square root, which is in turn different from the environment of main. They have got no relations with one another. This n does not have any impact on the value of this n. The value of this n is absolutely common to it. You may say that over here I am having n. When I was passed, I was having a value of 5. So I was passed to n. So inside this fact, I have used I and I have changed it. So what will happen? Nothing will happen. When you return to main, I will resume from its old value 5, because this I has got no relation with this I. This I cannot change the value of this I. This I is common to it. Are you getting my point? This I is absolutely only local to main. This I is not common. This I is not same as this I. Within this fact you can have any value. Suppose you are sending a value of value equal to 5, I equal to 5. When you are calling fact, I was 5. Now inside this you are changing I, and when you return product, I has become say 8. When you return over here, again I will have its value 5, because within main value of I was 5. Within fact, what you do with the value of I is different. That I is local to fact. It is different from this I. Is that okay? Clear? So same over here, this n is local to square root, does not have any impact on the n of main. So over here, how will I calculate the square root? I can use the same concept of float I. Okay, one thing, product needs to be declared over here. Okay. Similarly over here, I will need a float. Float what? The number where I will receive the square root, I will need a I. Is not it so? So this I will now iterate for I is equal to, the lowest square root possible is say 0. Even over here n can be 0. I don't know what will be passed to square root. I know over here that I plus 1 nothing less than 2 can be passed, because I will enter with I equal to 1. So nothing less than 2 can be passed over here. But when I am writing the square root function, I am writing it in a way that it can be called from anywhere. Any function anywhere can call it. It can be a common function. So I will have to assume that even 0 can be passed. So I will have to over here start from 0.00, because I know square root of 0 is 0. So 0.00 I will have to start and increase I by 0.01 every time. And every time I will have to check if I into I into I is greater than equal to what? Float of n. N is the number whose float you are, whose square root you are trying to find. This n will receive the value of I plus 1. If I is 2, I plus 1 is 3 in main. If I is 2 over here, I plus 1 is 3 in main. So 3 will be passed, but this 3 will be received in n. And after that I changes, n changes over square root, doesn't matter, that will have no impact on the I and n of main. I and n of main will keep its own value intact. When you return, it will start from its old value. I think you understand. So if I into I is greater than equal to float n, you know you have received, you have already got the square root. What you need to do is, you need to break out. You break out from the for loop. Once you break out from the for loop, what to do? You will only need to return. You will need to return a float, means you will need to return the square root. Where is the square root contained? The square root is contained in I. So simply return I. I think you understand this. You simply return I. So that I, where will it be received? That I float will be received exactly at the point from where it was called. It was called from here, so the square root will be received over here, but you are writing y equal to that, so that will be again assigned to y. So x and y will contain the value and the sum will be calculated. So over here you see, you have done fact and square root yourself. But that fact and square root are two functions. When you are calling those two functions, you are saying that these two functions I am only going to use, and they are going to return the values to us. I am not concerned about what is the content within fact, how is fact written, how is square root written, I am not concerned. This helps you to write the program or divide the program into different units. There will be big programs where you can differentiate it into units and write. I think this is clear for all of you. So if you run this program, this should run, but one more thing is necessary. See, there are three definitions associated, which I will very quickly tell you. One is called prototype of functions. Another definition is arguments. Another definition is parameters. What are they? Prototype means, prototype is the function prototype. How does the function look like? Here you are saying fact is a function which will receive an integer and will return an integer. It is the prototype of fact function. I repeat, fact is a function which will receive an integer and will return an integer, is the prototype of fact. If somebody asks you, what is the prototype of square root function? You will say square root function receives an integer and returns a float. That's the prototype of square root. I repeat, somebody asks you what is the prototype of fact? You will tell prototype of fact is it will receive an integer and will return an integer. If somebody asks you what is the prototype of square root, you will say square root's prototype is it will receive an integer and will return a float. I think you understand this. So that is the prototype. Now the prototype needs to be defined right before it is called. You are calling it from main. Over here you are calling it. But prior to that it is not defined. You are defining it over here. So it is necessary that you define the function prototype before calling. So over here you need to define fact and square root prototype. How do you define it? Just by writing its prototype, that is, it will receive an integer and will return an integer. Just to show you once, see if you run this program now. If you run this program now, it will give you an error. See what error it gives? 6 errors. Okay. I have not defined. Here it is not defined. You please do that. You need an int n. You need an int I. Is not so? You need an int n. You need an int I. You need an int x. You need a float y. Because square root of I plus 1 is float. So float y. And you need a float sum. So these things you need. So over here sum is float. Y is float, so sum equal to x by y will be float, but x is an int. Just for your safety you can also typecast it to float. Because you know x is an int, you can typecast it to float. So you have defined n, you have defined I, you have defined x, you have defined sum, so everything you have defined. So you think that everything has been defined, you should be able to run the program now, but see what happens if you run. One error. It says function fact should have a prototype. You have not defined the prototype of fact function. You have not defined the prototype of fact function. Are you getting it? So prototype of fact function has not been defined. Now one thing I will show you, just for a thing, I had written something wrongly. Let me delete this part. Sorry. At the top you have conio.h, stdio.h, conio.h, stdlib.h and hash define n. You run this one, there should be 2 errors. See, 2 errors. Function fact should have a prototype. Function square root should have a prototype. See, what it means is you have called fact, you have called square root without defining them. You have defined it later. Prior to it, it does not know. So you must define the prototype over here. How to define a prototype? You write int fact int. You may not write n also. You just write int fact int. It means that prototype of fact function is it will receive an integer variable and will return an integer variable. Prototype of square root is float square root int. It will receive an integer and it will return a float. I think you understand. But over here you are not defining int n because you are not actually receiving over here, which you need to define over here, because if you don't receive in n, then whose fact will you compute? If you don't receive in n, then whose square root will you compute? So to compute the square root or the fact, you need the variable, so you are receiving it in n. But over here you are not receiving, you are only saying that the prototype of fact is this. As if you are introducing this fact and square root functions to the main function so that the main function can call it. You are introducing it. You get my? Before running the program, one thing I can see over here is this is plus equal to, I missed out this equal to. So I plus equal to 0.01. Now if you run this program, it should not be showing that error of prototypes. Why not? Because prototype have been declared. I have declared the two prototypes over here now. So once these prototypes are declared, you have told to main that these two fact and square root are there. It will receive one integer and fact will return one integer. Square root will receive an integer and will return a float. So you have defined that to main, and now you can run this program. So let me run it. You will see the same results. Say with 4, see 15.55, the result you got to see earlier. Say with 5, 64.5. Say with 3, 4.83, and you remember with 2 I showed you, it's 1.85, something like that. So I think you have understood this. Now what about this argument and parameter? Argument is the actual value that you are passing. Argument is the actual value, this I and I plus 1, the actual value that you are passing is called argument. So what you pass to a program is the argument, and the definition, that is int n, or maybe this definition int within the prototype, these are the parameters that it will receive. It has got the parameters int within it, so it will receive an integer, that is parameter, and the actual value that you are passing is the argument. So that is the definition of argument and parameter, and prototype is the function's definition. So over here prototype was already declared, but you needed to declare it early because before main you have called it in main. So before you called it, you have shown to main that this is the prototype. It will receive one integer and return one integer fact, and square root will receive an integer and will return a float. So I think you have understood this. So we have run this program. We have seen this is working fine. So you have understood the difference between argument, parameter, and also you have understood how function prototypes need to be defined. One question that I will answer before I close this is that what if this in fact has been declared outside of main? Can I declare it also within main? What I mean to say is, if it is not there and I run, it will show error. Two errors. What errors? Function fact should have a prototype, square root should have a prototype. Now if I define it over here, fact and square root, then will it work? Say int fact int. I declare it over here, not outside main but inside main. Will it work? Float square root int. Will it work over here? See whether it works. Yes, it works. It works absolutely fine. So what is the difference of declaring it outside main and inside main? See, if you don't declare, once again it will not run. Just remove this. See, this will not run. It will show errors. But if you declare it within main, still it runs. If you declare it outside main, still it runs. What is the difference? The difference is, if you declare it within main, then you can call fact and square root only from main. Now say from one function you need to call another function. From fact you need to call square root, or from square root you need to call fact. Say for example, generally you will never need to, but if you Need something like that, that from one function you need to call another function. Then what? Then it will not work if you declare within main, because only main knows fact and square root prototype. If you declare it outside main, then you have told that everybody knows the prototype of fact and square root. So fact can call square root can call fact, because you have declared it globally outside of main. So outside of main means now any function can call it. But if you define it within main, then only main can call it. I think you understand this. Another logic that I will show you is, say, if I don't declare square root, if I don't declare this square root, if I avoid declaring this square root, and suppose the square root function is not there, I avoid declaring the square root I am not declaring, I avoid writing the square root, and suddenly run this program, what will happen? Definite error. What error? Function square root should have a prototype, that is, you have not defined the square root function, and you are saying that you are calling that square root function, neither you have defined it over here, nor you have defined it, actually defined the meaning of that. But one thing you can do, if you hash include math.h, then suddenly it will start running without errors. See what happened? See, this square root function is defined, is already written as an inbuilt function of C, inbuilt library function of C within a header file called math.h. If you hash include that math.h in your program, then you don't need to write the square root function yourself. You can totally avoid the square root function and you can call it. You can call the square root function without defining it. If you include the math.h, because math.h already contains the square root function predefined. So do you understand the meaning of header files? You will understand more. But for the time being you can understand. See, stdlib.h, why is it needed? Because if you call malloc function, malloc is also a function which is defined within stdlib.h. Why do you need conaio.h? Because this clear screen function and getch function you have not written. See, it's a function, you are calling it. You have not passed any parameter, it does not need any parameter. But if you call the clear screen function, it does not need any argument to be passed, it does not have any parameters. But if you call those functions clear screen and getch, clear screen clears the screen and getch waits for a key press. So these functions are predefined within the header file conaio.h. That's why without conaio.h, clear screen and getch does not work. Like over here, square root function will not work if you do not hash define math.h. If you do not hash define math.h, then square root function will not work. You run it, it will say square root function should have a prototype. Then you will need to define it yourself. Then you will have to write it yourself. Like you have to remove this comment, you have to remove this comment, you have to write the square root function yourself, or you will have to rely on a predefined library function of square root which is written within math.h. So like that, if you hash include math.h, you can easily use the square root function which is written within math.h already. You don't need to write it separately like you had done over here, but you don't need to, because it is already there in math.h. You can simply hash include that math.h. I think you understand that. Are you getting my point? So that is what is this hash include stdio conaio are doing. Conaio is hash included because you are using clear screen getch. Achha, why do you hash include stdio.h? Because you are calling a function called printf, scanf. These are all functions. See, printf, this is a parameter that you are passing. %d as a string, this is a parameter you are passing. This is a parameter you are passing. That's why a comma in between. This is a parameter that you are passing to a function called printf. These are parameters that you are passing to a function called scanf. How are those printf, scanf written? That you will learn later. That you need to learn many things of computer before you learn how printf, scanf are written. But printf, scanf are already predefined functions within the stdio.h header file, which is a predefined library file or predefined library function. Printf, scanf are there within the header file stdio.h. So to use printf, to use scanf, you need this stdio.h. I think I could make you explain why stdio.h is needed, so that you can write printf, scanf. Why conaio.h is needed, so that you can write clear screen get ch, because these are functions, clear screen get ch, printf, scanf, which are written within those header files. Like math.h, you have hash included and you could use square root function without writing it yourself. However, if you avoid hash include stdio.h, you can write square root function yourself. But I think you have understood how functions are written. We will write more programs with functions, or in fact we will write many more programs with functions as we come back after a little break. Thank you so much. Let's take a bit of break and come back.